Welcome to this introduction to the DLC's new toolkit to help you integrate network lighting controls with heating, ventilation, and air conditioning controls. My name is Levin Knock. I work as a Senior Technical Manager at the DLC, and I'll be your host today. Let's start with some logistics. Everyone's microphone is muted, so if you have any questions about the contents as we go along, please write them in the GoToWebinar questions pane. We might be able to address some during the presentation, plus there will be time at the end to address more questions. If you have technical difficulties about tuning in, please write them in the chat window. After today, a recording of this webinar will be available on the designlights.org website under the Resources menu as an on-demand webinar. As you may know, the DLC, or Design Lights Consortium, is a nonprofit organization that promotes high-quality, energy-efficient lighting products for non-residential buildings in collaboration with utility energy efficiency programs, lighting manufacturers, and other stakeholders. Since 2016, I have helped manage our list of network lighting control systems that are eligible for energy efficiency rebates and incentives across many parts of the United States and Canada. Today, we're going to watch a recording of a presentation at the recent AHR Expo on air conditioning, heating, and refrigeration. I'll introduce you to the DLC Integration Toolkit, and then Ron Bernstein, a Master Systems Integrator, and Matthew Turk, a specifying engineer, will discuss the toolkit's value from their perspectives. Ron will be available for questions, but Matt was not able to join us today. In the agenda, we are almost done with the introduction. After that, I'll play the recording for topics 2 and 3. Then I'll talk a little about recent developments in standardized digital protocols for network lighting controls that are making some network lighting control systems easier to integrate with other building systems such as HVAC. And as I mentioned earlier, please enter any questions as we go along so they can be addressed at the end. And now I will see if I can play this video.
Buildings have delivered affordable and reliable energy savings for electric utilities and for building owners. But now, with efficient LEDs already installed in many buildings, utility programs need new sources of energy savings. Network lighting controls, or NLC, could help, but they often seem expensive compared to the relatively small amount of energy they can save when the only load they control is LED lights. Still, when network lighting controls do manage to make it past value engineering and get installed on a project, they provide powered, networked occupancy sensors everywhere throughout a space. In suitable buildings, signals from those occupancy sensors can inform the HVAC controls to relax the temperature set points by a few degrees in all unoccupied areas. Some buildings can also reduce the ventilation rate for additional energy savings. As you probably know, this is called occupied standby mode. It depends on occupancy sensors that might or might not be part of a network lighting control system. Today's commercial buildings use more than half of their energy for HVAC and about 10% for lighting. The total combined savings from new LED lights with network lighting controls integrated with HVAC for occupancy standby mode can be over 20% of the whole building load. Substantial energy savings like that from NLC HVAC integration can be your key to helping building owners unlock rebate incentives and lower utility bills by taking a step beyond common practice. Energy savings from systems integration can be attractive to building owners, especially for people with buildings larger than 50,000 square feet that already have a building automation system and may even be subject to building energy performance standards. Occupied standby mode is also feasible in some smaller buildings, usually with old-fashioned analog dry contact technology. But soon, thermostats with Wi-Fi or Bluetooth connections will support plug-and-play digital versions of occupied standby mode in smaller commercial buildings without full-blown building automation systems. Building automation to coordinate different building systems is the wave of the future. Integrating lighting controls with HVAC controls is a good place to practice building automation to apply in the future across more building systems. Those are some of the reasons why lighting HVAC integration is worth pursuing. However, it rarely happens today. So the DLC has been working on ways to help it happen more often. Before I show you the DLC's new freely available integration toolkit, I need to take a minute for a few definitions. The term network lighting control can mean different things to different people. For the DLC, it means a combination of sensors, network interfaces, and controllers that effect lighting changes in luminaires, retrofit kits, or lamps. These devices may communicate with each other using a wired protocol, such as DALI 2, or a wireless protocol, such as Bluetooth NLC. When sensors for occupancy control and daylight harvest are on board every fixture, that's called luminaire level lighting control, or LLLC. That's good for spaces of all sizes and especially good for smaller buildings. I'm treating LLLC as one kind of network lighting control, or subset. Some network lighting control systems are connected to the internet, while some are not. Others have an occasional internet connection over the operator's mobile device. That concludes the definitions. So now we'll explore the result of 2 years of work at the DLC under the guidance of researchers and advisors from both the HVAC and the lighting industries, which is a new toolkit to support NLC HVAC integration. The toolkit will help you choose appropriate projects for integration that are likely to save energy at a reasonable price. They will help everyone on an integration project work together more effectively, and they will help your team create successful projects that save energy by providing lighting, thermal comfort, and ventilation only when and where they are needed. My goal in this presentation is to introduce the toolkit to you so you'll know what's in it in case you ever want to use it. And second, to ask for your feedback in the Q&A session later and also anytime afterwards. If you want to share your experience using the toolkit, or you see ways that DLC could improve future editions. The toolkit contains 5 different files bundled up in a zip file. First is the handbook, a concise reference manual. Next is the decision tree, a guide to help you choose appropriate projects for NLC HVAC controls integration and to avoid projects where success is unlikely. Next, there's a spreadsheet list of case studies of 18 integration projects so you can read about projects like yours, including lessons learned. Files 4 and 5 document an example project and can be edited to apply to your own project. The responsibility matrix describes major tasks and participants, showing who is responsible for what, and the project template is an example construction integration specification aligned with CSI Division 25 on integrated automation. Next, we'll look at some of these documents in more detail. The handbook is a concise reference manual with the different sections shown in this table of contents. The definitions include a few pages of essential terminology, and standards listed in the references at the end define many additional terms that might be new to some readers. The goal is to help everybody on an integration project understand a little about what the other people are doing. For instance, people experienced in lighting controls will already know most of what's in the NLC section. But if they read a few pages about building automation and management systems, they might be able to collaborate better with folks working on those systems and vice versa. The best practices section has standardized recommended best practices for everybody, and including how to write a good sequence of operations in the world of lighting and also in the worlds of HVAC and building automation. The decision tree diagram has 7 topics to consider when deciding whether to pursue NLC HVAC integration on a particular project. This one-page diagram is sufficient by itself to eliminate some projects from further consideration. If a project might have potential at first glance, and you want to consider it more carefully, each topic in the diagram has a corresponding page in the PDF file with a number and a color for that topic. You can click on a topic number in the diagram to navigate to the page about that particular topic. Next is a list of case studies of NLC HVAC integration projects. This zoomed out view shows all the data in the Excel file. Each row describes one of the 18 case studies, and each column addresses one topic. The data can be easily filtered based on any of the topic headings. Most of the projects are retrofits, but a few are new construction or major renovation. Here's a list of all 22 column headings. You don't need to read them all here because I'm going to go through them in the next 3 slides. The first 9 topics are all pretty short, as shown here, such as building type, location, square footage, building characteristics, and which systems were integrated. The next 4 columns have more extensive text with a summary of each project, a description of the project objectives that drove the decision for integration, a list of lessons learned, and an overview of the control strategies that were used in each project. And then there are columns about the HVAC system type and schedule, energy saved, payback, incentives, date, and the source website where you can find the full original published case study. You can see that some of the cells are empty because some case studies did not address every topic. The 18 projects include these 7 different types of building, so you can see how some of the control strategies and integration objectives varied by building type. We aim to make the list larger as we find more case studies that are suitable. There are also 2 templates in the toolkit that you can edit to help manage who's doing what on an integration project. A responsibility matrix in Excel linking people with tasks, and a CSI Division 25 contract excerpt for integrated automation to specify what needs to be done. That concludes our tour of the main features of the new DLC NLC HVAC integration toolkit. Please try it out. And if you do try it out, I would love to hear about your experience with it in terms of what works and what could be improved. Documents systems. This toolkit will help you choose appropriate projects, will help everyone on the project work together more effectively, and will help your team create successful integration projects that save energy. Next, we'll hear from Ron and later Matt about the toolkit value from an integrator's perspective, and also from Carol and Simon about recent developments in 2 powerful digital standards that can make lighting systems much easier to integrate with compared to the old analog systems.
I want to talk a little bit about what we've learned over the last period of time since we've been working on this and collaborating and trying to bring this concept of a network lighting, let's call it infrastructure, into the bigger building automation and controls market. Early on in the first round of research that we did, we were looking at the opportunities for the lighting market to broaden its, let's say, footprint beyond just reducing the energy cost by moving from fluorescence or incandescence to LED, which is the big low-hanging fruit. When that's done, the energy alone of lighting has a minimal level of gain, a step gain from where we were with incandescence. But what we have learned is that the lighting infrastructure offers us a tremendous opportunity to utilize the more pervasiveness of the lighting system for adding sensors. Now, the most obvious one is an occupancy sensor. But if you look at where lighting systems are in this room versus where our HVAC interface for this room is, there's maybe 100 to 1. So if we start looking at where we can add value, I'm a believer that the lighting system offers a tremendous opportunity for advanced sensors such as humidity, potentially sound and sound masking, gunshot detection, if those are familiar with that, advanced air quality sensors as well. So we started looking at where these 2 things might work, and the most obvious one started off with an HVAC occupancy and lighting occupancy working together in a common sequence of operation. So we held the summit, the DLC held the summit last year, and at that summit we presented these concepts, and probably the most important thing we took out of it was that people aren't asking for integration, they're asking for these positive outcomes and efficiency and systems working together, which we all took to mean we need better integration, meaning that we need to be able to share data. So there's some very good opportunities here. So we started looking at, well, how can we move to a smarter system? If we talk about the general smart system from specific, measurable, actionable, reliable, and timely systems of a smart building system, we hear a lot at this show about how we make smarter buildings. Well, the bottom line of that is communication. It's the ability to share information in an open, interoperable, understandable way. BACnet has done a great job with that. Other technologies are also in that world of standardization of information so that they can be non-siloed and cross-discipline. So the ability to consume and produce data or information is another aspect, and the ability to act and respond to change. And I like using, hang on, get my mouse back over here. I like using this diagram that says data starts with signals. The data of an occupancy starts with that passive infrared sensor saying, contact closure, we've got somebody in the room. And then we add information and context and the actionable information on that to get up to this level of wisdom and being able to do something with it and repeatedly being able to do something. So as we increase our data set context, we get greater value of that data. Well, part of the effort that we're working on here in the DLC is to make that data more applicable to an overall building automation project and also define it in the way of the smart buildings world. So here's a kind of my definition of a smart building that enhances the performance, increases the ease in operation, improves the cost and the facility ownership level. It's a higher performing environment where we don't have single, standalone siloed systems. We have more integrated systems. They are operationally more advanced. We can see more information. We can take action on them. We can do greater fault detection and diagnostics, more predictive maintenance, and we offer greater comfort and satisfaction. So a few others on there. That's sort of my broad definition of a smart building. But when we're talking about this project, we're really looking at the operational efficiency and also the energy efficiency. Now, as we're moving to electrification and decarbonization, which if you've been to any of the sessions between ASHRAE and AHR, you've heard those terms. Those terms are pervasive in our industry now. We're moving towards more demand on the electric side, more heat pumps, with lighting systems being, again, very focused on the energy efficiency and the operational efficiency. We start getting these project goals that overlap. And when we do those overlapping goals, we also have to take into consideration the cybersecurity. So that's a whole nother topic we won't spend a lot of time on today. There's actually a session going on right next door on security and zero trust of building automation systems starting right after this one. So we want to make sure that the data that we're getting in the toolkit, there is some discussion about what information comes out of the NLC, the network lighting control system, that's useful for the HVAC system. So as we extend those systems and converge those systems, that overlapping information can help the system designer, which Matthew over here is going to talk a little bit about, as to the value of using that information in a more concise and operationally efficient way with the sequences. So we get greater value, better decision, and better modeling of our buildings. So as we look at some of the objectives of a framework around connected systems, we have our objectives, we have our components, and we have the teams. All of these three things have to sort of work together. So I won't spend a lot of time on that, but the idea here is that it's not just the designer, it's not just the specifier, it is also the vendor, the solution provider, the integrator, and it all starts with the owner. The owner saying this is important to us. So when we design a spec, there are lots of things that go into our system specification. It's not just, hey, make these two things work together. Are there any specifiers in the room other than Matthew? Okay, so we've got two. All right, so you guys are really in the driver's seat of how this industry is going to work together, is writing a good specification. I include myself in there. And one of the challenges that we have, if you get down to the brass tacks, is if we have a building, what does that building's lighting zones look like versus what do the HVAC zones look like? And is there overlap in the design so that we can use the lighting occupancy sensor or sensors in a space to effectively change how we operate and control the HVAC system? So we have to have some harmony in the design there. That shouldn't be designed in silos. We ought to be thinking about, oh, how many sensors are there in the room? Which ones would affect which air handlers? How do they overlap? And what data can we get out of those? And how do we maybe use that for our sequence of operations? So there's the start with this toolkit from the DLC will have great advantage to the lighting market influencing HVAC. And I think the HVAC industry will learn a lot from the lighting industry about how to work better together. Part of all of this is ensuring we have one unified system, that things work with each other. Well, that doesn't necessarily happen unless you have what I refer to as both the CapEx team and the OpEx team working together. Because oftentimes if you do a siloed project with just HVAC and mechanical in one bucket and electrical and lighting in another bucket, and they never talk with each other, and they're not working with the operator, it's part of the operational budget, you're not going to get that harmonization benefit. And also thinking about the ongoing incentives, utility incentives for energy reduction, all of that has to play together in a harmonized environment. So we want to maximize the efficiencies and outcome by looking at both sides of the coin and try and reduce that finger pointing. Says, hey, my system doesn't work because your data doesn't work, or I'm not getting your data in the correct way. We try and reduce that through standards. And we've now introduced, just the last 2 days, I helped introduce these concepts to the ASHRAE Specifying Building Automation System project, which is guideline 13, if you're familiar with that. So we're looking at enhancing the lighting section of that document to include some of these concepts. So.
Thanks, Simon. Matt Turk here, Newcomb and Boyd. Thanks for the introduction, Ron. So I'm going to kind of quickly try to summarize what we've been going over here today. Right, so at the very beginning, what this tool set can help you do is if you're an owner and you want to set a design vision or you want to have a standard, there's information in here for you. Or if you're a design consultant and there's information that can help you potentially in this tool set, right? Now I do a design, like I'm a designer, I'm a designing consultant. I do this every day of the week. This is what I do for multiple systems across various platforms. It's going to help you if you need to select pieces of equipment, understanding what to select and how to select it, right? You're also going to have a better understanding of how you're going to have to deploy your network potentially, whether that's a wireless network, whether that's a wired network. And then if you're going to deploy a network, how are you going to secure your network and how are you going to secure the devices on your network? There's information here which can help you potentially with that, which is great. So if you're working on the delivery side, hey, I know I'm going to need to plug this thing in somewhere. And I also am going to know like, this is what I need to adjust on my device so that I'm going to comply with my owner's standard. I'm going to put a password on it. I'm going to make this password to a certain standard and we're all going to be good. And I'm going to specify that that's going to happen because the owner told me they want a directive to do it, right? Finally, I'm going to have standards that are going to be developed so that I can properly configure my system. I got to perform a sequence of operations and I need to document it too. If we're going to share data between systems, there has to be a correspondence to the physical reality above us in a building. Something may mean like a set of numbers and a bunch of data, but that doesn't necessarily mean it corresponds to actual physical location, which is why the documentation section right now is so important. Hopefully more systems will self-document in the future, but most of them don't do a good job of doing a geopositional type of documentation. Finally, we're going to need to commission our system. So if you've seen traditional delivery of HVAC or lighting, you traditionally have a commissioning agent. They're going to come out. They're going to check it. They're going to make sure it functions right. Well, what happens when then you need to do an integration? If you're sharing data between the various systems, you can have that system programmed and finished potentially, but you haven't necessarily programmed the other system, which is going to consume the data outside of it. So what's going to happen with that? Well, what you can do with this framework is you can help define the activities that need to happen for that integration to occur, right? And then finally, we're going to get to a new step that's going to happen on all the projects. How are you going to do this? Are you going to validate that you have the integrated commissioning? Are the sequences set so that they can be formed properly, right? And then if we do all that correctly, we'll get a building and everybody's going to be happy because we're going to get the experience the owner wanted when they defined their standards or their owner programming requirements at the very beginning. And everybody walks off the project and everybody's happy. And it's what the best part of it is. Now you also see kind of on the left side here, there's some potential options for some new roles you may run into. You may see a master system designer. Traditional MEPs delivered in buckets and silos, the same way traditional verticals you're used to. Plumbing is plumbing, HVAC's HVAC, lighting, Division 26, plumbing, Division 22, HVAC, Division 23. You have silos. You're going to have someone who can go in between those silos and bring it together for you on the design side. That's what I do a little bit. And then you can almost think of that master system designer as your architect for your systems and how the systems are going to go. Then you're going to have your typical systems integrator. If you work in HVAC, you have a vertical there. Maybe you want to evolve and you want to become a master systems integrator where you can do multiple systems. Or maybe you want to say, hey, this is my silo. I'm going to stay on it. But I'm going to know who I can work with in the industry who can actually perform this role for me. That'll be great too, right? And then I finally got to get into commissioning. There's also a lot more variety we can do here now with more data. If we do a good job of this integration, we can actually have this integrated commissioning be more of a process where you validate the data itself and you don't have to go on site anymore. Instead, you can do that remotely with algorithm, with AI potentially in the future, or for now, just with someone who actually understands how the building's been intended to perform, right? So there's a little bit more here. Here's this example of what some documentation might look like if you're receiving something from me, right? So we had this responsibility matrix we talked about. That should be a part of your documentation. You might see something like the top left-hand corner. These are the system points that need to be shared. I'm going to establish what that is and let you know how you're going to get about doing that. And then finally, you kind of have somewhat of a network topology. How is this actually going to go together as like an architecture? All of these are key elements to making sure this happens. And there's information in this DLC toolset to help you get started on this road and make that possible. And with that, I'll hand it back over to Ron.
Okay, I want to say thank you to all of our speakers. Everybody did a great job. Let's leave you with a grand vision. So forgive me, but this is my grand unified vision, that all building systems will work together and share information across an open control networking infrastructure, allowing any device, subsystem, or system or building to produce and consume data without the need for closed or proprietary components, and where all systems and applications reside in an open, integrated, secure, interoperable environment. Can I get a hallelujah? All right, there we go. Well, we're taking steps. I've been at this now, almost 35 years or so in this industry. We've come a long way in 35 years, but I still think we got a long way to go. The next world that we're going to be living in, AI, enterprise systems, cloud-based systems, service as an industry support, lighting as a service, HVAC and refrigeration as a service. We're going to start virtualizing a tremendous amount of this. It all then comes back down to this core level of interoperability, effectiveness, and efficiency of the low-level devices and systems to working together. So the NLC Toolkit is a great step in this direction, thinking outside of our silos, which we all need to do. The HVAC industry has been very, very silo-focused since the beginning of my career, but we're starting to open that up by inviting others in. And there are other sessions here at both AHR and at the ASHRAE side that are talking about cross overlap between other disciplines. We need to do that if we're going to get into this whole building and smarter building design. So with that, the toolkit information, if you missed it, if you didn't get one of the flyers, there's the link. You can click on that link or go to designlights.org and you'll be able to download the toolkit and learn more about that. And we certainly welcome your feedback. So we're looking for how effective this is. Are we on the right track? Is this something that you can see us expanding? Are there things that we're missing? Those are the things that we're looking for. And with that, I want to say thank you to all of our speakers and to all of you. Big round of applause to everybody.
And there we are. So now this next section, I should mention that I've condensed the section by in the AHR presentation. Carol Jones of the DALI Alliance and Simon Slupik of the Bluetooth Special Interest Group talked about their respective standards. And so I've condensed that a little in the interest of time, so I'll have some time for questions. So recently developed open digital protocols are supported by rigorous certification programs that support reliable, predictable performance, even when you mix and match components from multiple vendors. For integration projects, you can get reliable digital sensor data out of these systems in a standardized format. I'll update you on two of those open certified protocols and how to find NLC systems that use them. But first, I want to show you why standardized reliable performance is such a big deal. In the past, lighting controls have depended on communication protocols that were difficult to maintain over time and difficult for other building systems to work with. Proprietary protocols only work for one vendor's products, and analog protocols are unreliable. For example, if the analog 0 to 10 volt protocol was reliable, then this chart of analog dimming control input signals on the x-axis versus the output power from 24 different streetlight drivers on the y-axis would show all of the slanted colored lines as one single identical line. The DALI Alliance promotes DALI, Digitally Addressable Lighting Interface, for digital communication between lighting control devices. DALI-based wired lighting control systems are common in Europe, and recent developments are gaining popularity in North America. In 2017, the DALI 2 protocol was published for wired networks between luminaires and other devices. DALI 2 requires certification testing to support interoperability between certified products and defines protocols to manage data from sensors in a standardized way. In 2019, the D4I protocol for communication between components within a single luminaire was adopted in North America as the ANSI C137.4 standard. LED drivers that support ANSI C137.4 communicate digitally with sensors and controllers and use North American power supplies. This yields standardized digital data that other building systems can interface with. And since 2021, the DALI Plus protocol brings DALI open standardization to wireless networks between luminaires. The other big thing happening in digital lighting control standards is Bluetooth. In 2010, the Bluetooth Low Energy standard addressed the radio layer of a network lighting control system where devices transmit wireless data over radio frequencies, but for the communication and device layers, each different product used a different proprietary solution. In 2017, Bluetooth Mesh addressed part of that problem in 2017 by standardizing the communication layer, but the device layer remained proprietary. Only since 2023 has a full stack standardized Bluetooth wireless mesh solution become available. It's called Bluetooth NLC, and it supports multi-vendor solutions for network lighting controls, so you can now buy a wireless lighting control system with no worries that the vendor might go bankrupt and leave your equipment stranded without service support. In large buildings with a building automation system, a Bluetooth NLC lighting control system can communicate with the BAS through a BACnet gateway. For smaller spaces with no building automation system, a new Bluetooth NLC component profile is coming soon to let Bluetooth-enabled thermostats communicate directly in a standardized way with the occupancy sensors of a network lighting control system. This will support lighting HVAC integration even in smaller buildings with no BAS. To find products that use standardized, certified digital protocols such as these, you can check out the DLC's list of over 90 different network lighting control systems. You can filter the list for products with various capabilities, including those shown here that are especially relevant to lighting HVAC integration. On the designlights.org website, once you've logged in with a free account, you can choose Find Products and then NLC QPL. To see the whole list of 90 network lighting control systems, you can use the filters on the list left to narrow down the selection. Or to get a spreadsheet of all the detailed data, you can make a list of all the systems you're interested in and then download all the data from your product list to an Excel spreadsheet that has a row for each NLC system on your list and a group of columns for each of these 22 capabilities that DLC collects data on, for a total of more than 120 columns of information about each system. To recap, in conclusion, the DLC has published a toolkit collection of 5 documents that is freely available for you to use on projects to integrate network lighting controls with HVAC controls. These documents point to several additional resources, one of which is the DLC list of network lighting control systems, where you can see which systems support which popular digital standards to make your integration projects run more smoothly because they manage sensor data with open digital standards. This toolkit will help you choose appropriate projects, will help everyone on a project work together more effectively, and will help your team create successful integration projects that save energy. And now let's see what questions we've got. And I'll leave up the address of the DLC's webpage with more information about NLC HVAC integration, including where you can download the toolkit. So now Stuart Brzezinski is going to lead us through the questions.
Yeah, so Levin, there's a lot of good questions. I'm not sure if you can see them, but I'm going to start at the first one down at the bottom here. Um, so the first question was, many utilities do not provide rebates for HVAC integration for various reasons, including the measure is hard, or it's hard to measure the savings, or the savings aren't guaranteed. And so then they tend to focus on equipment versus software. Do you know of any strategies or methods where the HVAC integration can take part of rebate programs?
So the closest one that I'm aware of now is what's called comprehensive incentives. And so I know they're popular in Connecticut, and they may be available in other places too, but definitely in Connecticut, where the idea is that the efficiency program wants to get a foot in the door. And once anyone gets in the building, they want to touch as many building systems as they can to really optimize the whole building for efficiency. And so, for instance, if someone's doing a lighting retrofit, they can get the lighting incentive, and then if someone else wants to upgrade the HVAC, then they can get an HVAC incentive. But if those people work together, like if the lighting person brings in the HVAC person to increase the scope of the project, then they get a bonus or an extra incentive because they touched more than one building system. So that's the one example I know of now, and I'm hoping that with this new toolkit, as we see some more successful projects, that more incentive programs will join in finding more ways to support them, uh, support integration more fully.
All right, thanks, Levin. Ron, this next question is for you, actually. There was a question, and I believe it was from your slide where you were showing the overlay of HVAC zones and lighting zones. So the question is, have you used AI at all or seen examples of AI being used for that overlay and the integration between them? And if so, how did the results pan out?
Well, to be honest, I have not been using AI in any of my design work. I do know that there are some AI applications that are doing modeling. So that's more pre-design or pre-construction of modeling how the zones might fit together. But it's more of an academic research rather than in use in real projects. So I couldn't answer that. I don't have much experience on the AI model. I will say that the overlap design, I think Matthew talked about a little bit, it really starts with a whole building design of understanding what are the requirements of that overlap between the various types of zones. It's not only the zones, but the types of zones and how those zones are going to be used. I think that is where some AI and using the modeling could help in the designer knowing how many sensors to put in, what the coverage of those sensors are, and how that would affect the sequence of operation for the HVAC system.
All right, thanks, Ron. I have another one, which I think, Ron, is probably best for you, but Levin, if you want to chime in, feel free. Do you have controls manufacturers that you can recommend that have the technology available to do this, so to do the integration itself?
Well, that's actually an interesting question because, in my opinion, it's not necessarily the control manufacturer that does that, but the controls integrator or the master systems integrator. So any controls manufacturer that's using an open protocol like BACnet can receive information from the lighting system. So it's not a question of the capability of the tool set. This would be the BMS front end, the building management system. It'd be more the question of, does the integrator who's actually integrating the job have the technical ability and the skill set to be able to take that data and do something intelligent with it? It does come back again to the specification that if the specification does say that the lighting's occupancy sensors are going to be used in HVAC, then that should be part of the sequence. And it should also be part of the design criteria for the points list and how that integration should happen under the Division 25 section of the specification. So the other part of the question is, can I recommend vendors? Well, I can recommend pretty much any vendor that's using BACnet and has a BACnet operator workstation and OWS type of BMS front end. They should all be able to do this because now we can receive the lighting control system data over BACnet.
All right, Levin, anything you want to add to that one?
Yeah, I'll add to. Thanks, Ron. I'll add to that, and also this next question: can you provide a schedule of hardware that integrates lighting with HVAC? So, for both of them, I think those questions came in before I described the NLC qualified products list. So there you can find information about uh, which different systems support the capability. For instance, which lighting control systems um, support external system integration. And under the topic of external systems integration, you can see details about some of the particular ways that they support it. Um, and then, so honestly, we don't have a schedule of for this one to provide a schedule of hardware that integrates lighting with HVAC. We don't have a schedule exactly in the toolkit. I think that maybe is a question for Ron, but I think it kind of varies depending on the project.
Yeah, it sort of does. There's two ways, well, actually there's three ways of absorbing the lighting information into the HVAC system. One is a direct connection between the lighting occupancy sensor and the programmable controller or equipment that needs that data. It would be the same as using like an outside air temperature sensor to give you that information to control your logic. You'd use the lighting occupancy sensor data over, let's say, a BACnet network directly into that controller. So it'd be a direct, what we call a peer-to-peer connection. That's method one. Method two would be to use a supervisory interface from the lighting system to a supervisory interface on the HVAC system. And those two systems, those two supervisory systems would talk with each other, either using a BACnet, or it could be a standard API, or a direct Ethernet connection with a data protocol on top of that, like MQTT or REST or one of those. The highest level would be using the BMS front end software to talk through an API directly to the lighting system user interface or to the supervisory controller. So there's three different ways to do that. And depending upon the project requirements, all three of them could be done. Most vendors would be able to support any three of those three mechanisms, but it really comes down to a product selection and specification project.
Thanks, Ron. There's a question that came in after you were talking about master systems integrator. The question was, who would that be? The HVAC control person or the lighting vendor? So maybe you can talk a little bit about system integrator, master system integrator.
Yeah, I can talk quite a bit about that one. So
Okay, I'll give you a minute though, Ron, so we can get through other questions. How's that?
yeah, that's a long topic. And let me just say the concept of a master system integrator has sort of grown out of this need for multi-domain and cross-discipline requirements. So it used to be you'd have a controls contractor, which was often the mechanical contractor. They then elevated to a system integrator that would integrate various things into the HVAC system. And they elevated to this master system integrator that has to integrate everything, but not necessarily into the HVAC system, but into the building controls, operations, and building management system. So the master system integrator sort of has to have a lot of fingers in a lot of different buckets. So need to know a lot about the different systems and how they communicate and how to do that integration. It's not super common in the industry yet, but it is becoming more prevalent as more Division 25 specifications are coming out. So I would say look for a Division 25 contractor, more than likely going to come out of the mechanical side since they're more pervasive there. But I'm hoping to see that we get more MSIs in the lighting market as well.
Great, thanks, Ron. I think this next question is for Ron. Can integration like this be utilized in performance savings contracts? And then how easy is it to quantify the actual savings potential around that?
Well, the short answer is absolutely yes. Anytime you can adjust the performance of the HVAC system by knowing when and where people are, and I go on beyond just occupancy, but occupancy and density of people and duration of people in spaces all leads to some very good performance uh, metrics that can be used to adjust the schedules and other parameters in the HVAC sequence of operation. So they can be measured. A lot of that measurement comes in equipment runtime and pre-cooling and preheating. So there are some good metrics in the HVAC side to capitalize on what we call an energy efficiency metric. So I won't go into the details, but the short answer is yes, it can be done. And once the data is there, the measurement and the monitoring of that becomes crucial. And I think Matthew, in his little pitch, talked about the need for measuring and metering and monitoring. That's all part of creating those metrics and having a baseline.
Yeah, thanks. And I will add, in terms of quantifying the actual savings potential, uh, there's a couple of resources in the toolkit that talk about ways people have built models, kind of a generic model to say what types, what a certain type of building might be expected to do. You can also look at the case studies to see how different building types respond. The best answer, though, is that Michael Poplawski at the Pacific Northwest National Lab is developing a energy model for a particular building, so that you could use his energy model to predict the savings at the project level from your particular project. And I think it's in beta mode right now. Um, if anyone from PNNL is on and knows more information, would you please put it in the questions or the chat? If not, then just get a hold of Michael Poplawski, and he should have more up-to-date information about exactly when he's ready to share that with people at what scale.
Yeah, Levin, I could add one more piece to that. PNNL is also working on something called the Energy Services Interface, which is that kind of in between the model and the actual building of how do you grab that information in an open, consistent way. So PNNL and a few other folks have been working on this Energy Services Interface. They've got something that they've run out in a trial called Voltron. That system basically looks at the energy from both the consumption, the generation, the utilities side, and starts putting those models together for building up kind of what you said of the model. In fact, Michael might even be using that interface. That's a standard published interface anybody can use.
All right, Levin, we'll start with you for the next question, and then Ron, I'm sure you'll have some feedback as well. So the question, Levin, is do you recommend to do motion sensors for each fixture or just the zone? Did Levin freeze just for me or for
That's,
All right,
that's a great image, Levin. I think we lost Levin
Oh,
there. Oh, there he
there,
is.
Levin, you froze for a second, so if you could
you're,
start your answer again. All right, now you're muted.
oh, thanks.
There you go.
Um, I'm muted?
Nope,
You're
now
okay.
you're good
Okay.
now.
Okay. Um, yes. So the best practice for getting the most granular data and the most energy savings is to use luminaire level lighting controls that have an occupancy sensor on every luminaire. And these these systems are easy to install in that many of them are installed just like a plain old regular luminaire with no sensors, but then you go back and configure them after they've been installed to optimize the energy savings. And people are developing now different ways to use this granular data. Chris Wolgamott at NIA has a project that they're running. We're trying out a couple of different ways to manage this data at a MW Connect headquarters in California. And so that the question of exactly how to use that granular data is still in process. But in general, the more granular data you have, uh, the better decisions you can make. For instance, if you have a large HVAC zone and there's one person in it, you may be able to distinguish that situation from when there's 20 people scattered throughout that zone.
Yeah, I can add a little bit to that. The more data you have, there's more things you can do with it. Levin, you mentioned one of them, which is density. How many people are in a particular zone? Sometimes you can't do that with one sensor, but if they're spread around and you can average those or accumulate those, density is a very good metric to use on the HVAC side because you can adjust your airflow based upon the number of bodies in the room. CO2 sensors do that as well. That's the typical way the HVAC world works is using CO2 sensors. And when there's more CO2 in the room, you know you've got more people, more bodies in the room. But one other thing that's really interesting about having a large density of occupancy sensors is you can use that to do traffic patterns. So you can know where people are in a space and what direction they're moving in and how long they're in a space. That's good for other things, maybe other than just pure HVAC. but there's some good value in that as well. And there's other things that you can do with that more granular data that leads to some of the energy metrics of how long people are in a particular zone in a space, which means how much time you need to run that air handler for that space. And you can do that over time. So that's more on the predictive side as well.
All right, and I think this is going to be our last question, and I apologize. There are several other questions that we're not going to be able to get to, but we will work to respond directly to those people. But Ron, we'll start with you on this one. With regard to occupancy standby mode, are there any concerns with how often the HVAC system might turn on and off?
Uh, in my mind, no. A good system design and program implementation will have the parameters inside the control logic for the air handling equipment to reduce that short cycling. We call that short cycling. You don't want to turn it on and off every time the occupancy sensor detects someone in the room. It's a time-based and event-based criteria simultaneously. It's not just event-based. So you would not say turn it on and off every time somebody walks in a room. It's going to be a time-based. If it's on for 10 minutes, somebody senses that they've left the room, then you might turn it off, or you might wait 20 minutes. But that's all part of the control logic for the environment.
Levin, anything to add on to that?
No, thanks.
Okay. Um, since Ron was efficient in answering that question, we might be able to squeeze in one more. I'm just trying to see here.
Oh, I see one.
Okay, go ahead,
There's
Levin.
a question for a site that already has an LED fixture. Is it still worth it to add one sensor for each? That's a really hard sell. That's why it's so important when you're doing a lighting retrofit. Anytime you do a lighting retrofit, that is the time to include this LLLC with the sensors because it's really easy to put them in then. But once you've got new LED fixtures, it's much more complicated to come back and add a sensor.
Yeah, and I might add to that that you can selectively choose which fixture to add a sensor and reduce your cost after you're doing a retrofit. You might have that mapped into a zone and get the perimeters of the zone. So maybe the four corners of a zone to know when there's occupancy rather than every fixture in the zone. So that, that's part of a good design is looking at the cost impact of putting those sensors in.
Yeah, and I'll just add one other piece to that. When you're a lot of original LED projects, indoor LED projects, are getting to the end of their life. So although you didn't have controls in it originally, when you're going from LED to LED now, it's a perfect opportunity because you don't want to lose out on, say, another 10 years without having controls in that fixture.
Great point.
So, Levin, we're at time, so I'll let you close out the webinar.
Thanks everyone for joining in, and we will try to respond to the rest of the questions one-on-one. But thank you very much, and that concludes our webinar.
Thanks, everyone.